Continuing with complex numbers, we are going to raise a complex number to a power. So I'm going to pick a complex number that I've used in some of the past videos. We have 2 plus 3i. And in one of the previous videos, we converted that to its trig form, and we said that the absolute value was root 13 and that the argument is 56.3 degrees. And so we can write it as root 13 times the cosine of 56.3 degrees, which would equal 2, plus I sine 56.3 degrees, which when we distribute the root 13 in, gives us 3i. Okay, so now what if we wanted to find what is z cubed? So we can do that the traditional way, and we can say that that is 2 plus 3i rather, cubed. Or we can say that it's root 13 times the cosine of 56.3 degrees plus I sine 56.3 degrees, and we could cube that. So I'm going to do it both ways so that you can see the benefit of having the trig form going forward. If we do it using our original rectangular form, we would say 2 plus 3i times 2 plus 3i times 2 plus 3i. And so I have to FOIL these first two out. So I would get 4 plus 6i plus 6i plus 9i squared times 2 plus 3i. Now remember, this I squared makes this a minus 9. So if I combine 4 minus 9, I get minus 5 plus 12i. And then I have to FOIL again. So because I have to multiply by the third one of these. So minus 5 times 2 is minus 10. Minus 5 times 3i is plus 15i. 12i times 2 is plus 24i. And 12i plus 3i is plus 36i squared. And again, that makes this minus 36. So we get minus 46. Let's see, I lost a negative sign. This is minus 15i here. That should be a minus 15i. And so we get minus 46 plus 9i. And so the cube of 2 plus 3i is minus 46 plus 9i. Okay, and I'm just going to sort of give us a picture of this down here. So I'm going to go way over to the left, minus 46, and then up 9, something like this. That would be minus 46 plus 9i. And if we, and again, this is the real and this is the imaginary. And so just before we go and do the other method, let's convert this to the trigonometric form. Let's see what we get. So if we were to do the absolute value, so we would have 46 squared plus 9 squared. So if we do that, we get the square root of 46 squared plus 9 squared becomes 46.9. So that would be the absolute value of z cubed. And the argument, oops, sorry, am I off the screen a little bit here? And the argument would be tan inverse of 9 over minus 46, and that gives us minus, let's see, tan inverse of 9 divided by minus 46. That gives us minus 11.07, but since we're in the second quadrant, we know that we have to add 180 to that. And so we get 168.9 degrees. And so we could write this number here, negative 46 plus 9i. That's also going to be the same as 46.9 times the cosine of 168.9 degrees plus I sine 168.9 degrees. Okay, so if we do it the traditional way, this is our answer. And just to remind us why we have the 168, I'll put the plus 180 because we know that 11 is this way. So that's the minus 11 degrees. And if I add the 180, I get to this direction in my third quadrant, or my second quadrant. Okay, so now let's do the multiplication, the raising to a power using the trig form. And I think you'll be able to see how this is a far more powerful way to manipulate with multiplication and division. So if I take this and I raise it to the third power, so let's think about that. That means that I'm going to multiply root 13 cosine 56.3 degrees plus I sine 56.3 degrees. And then I'm going to multiply that by itself, and then multiply by itself again. Okay, so let me just turn the page over here so that we have a little bit more room. So we have the square root of 13 times the cosine of 56.3 degrees plus I times the sine of 56.3 degrees. And then we're going to multiply that by root 13 cosine of 56.3 degrees plus I sine 56.3 degrees. Plus, multiplied again, times root 13 cosine of 56.3 degrees plus I sine 56.3 degrees. Okay, so these are our multiplications. And remember, when we do multiplications, we just multiply the absolute values. So we have root 13 times root 13 times root 13. And then we add the angle. So we have cosine of 56.3 and then plus 56.3 plus 56.3, which is just times 3, because I'm going to add it 3 times to itself. Plus I sine 56.3 times 3. And when we do that, root 13 times root 13 is 13, so we have 13 root 13 cosine, and then 56.3 times 3, if I add it 3 times, is 168.9 degrees, plus I sine 168.9 degrees. Okay, so if I go back to my earlier page here, and I say that I cube this, I get 13 times the square root of 13 times the cosine of 168.9 degrees plus I sine 168.9 degrees. Okay, now look, here's your 168.9 degrees, same. Now let's take a look, and I know the pink might be a little bit hard to read on the movie, so I'm just going to recopy this in black. Okay, so I just recopied that above. And so let's do square root of 13 times 13. So 13 times the square root of 13, and we get 46.9. So this is 46.9 cosine 168.9 degrees plus I sine 168.9 degrees, which is the same as doing it the other way. And I would argue that multiplying the absolute value, right? So we have 46.9 if we do it this way, and we had the same answer when we did it the other way. And I would argue that doing root 13 times root 13 times root 13, and then 3 times 56.3 degrees to get our angle, our argument, this is a lot faster than having to FOIL out. And imagine if you raised to the 5th power, it would be even faster. So the general formula for this is, if you want to take z is equal to the absolute value of z times the cosine of the argument plus I sine of the argument, and you want to raise that to the nth power, so I'm going to put that in brackets and say we want to raise this to the nth power. So like in our last example, we raised it to the 3rd power. Well, the way that you do that is you take the absolute value of z and you raise that to the nth power. So the square root of 13 cubed is what we did in the last one. And then for the argument, you would add theta plus theta plus theta n times, which is the same as n times theta. And so raising to a power, you don't need to do any foiling or any of that more challenging work with the manipulation of the I-squareds and foiling out. All you need to do in trig form is raise your absolute value to the nth power, and then multiply the angle by n theta. So let's just do one more example. If I had z is equal to 5 times the cosine of pi over 4 plus I sine pi over 4, and I wanted to raise it to the 6th power, I would do 5 raised to the 6th power, and then I would do cosine of 6 times pi over 4 plus I sine 6 times pi over 4. And that's a lot easier than having to FOIL out, FOIL out, FOIL out 6 times. So let's see, 5 raised to the 6th power, it's a big number, 15,625. And then 6 times pi over 4 is 6 pi over 4, which reduces to 3 pi over 2. Okay, and if you think about it, you know, we started out with 5 at an argument of cosine of at an argument of pi over 4. So this was our original number, and every time we multiply it, we add pi over 4 angle. So the second time we're here, and then the third time we're here when we're raising to a power, and then the fourth time we're out here, and then the fifth time we're down here, and then the sixth power, we're going to land on the 3 pi over 2, because when you multiply complex numbers, the argument in the trig form, they get added. So basically, when I'm raising to a power, every time I go up a power, I add that same angle. So pi over 4, and then I'd be at pi over 2, and then I'd be at 3 pi over 4, and then I'd be at pi. And what's happening is your absolute value is going up by a power of 5 each time. So your absolute value is getting further and further out. Okay, so there's some practice ones for these as part of the assignment for the week.